Let's make sure the YouTube stream is going. How's it going, Eldritch? Come on, YouTube. I can see it's like nearly live, if not already live. Do I have to refresh my YouTube page? There we go. Okay. So yeah, while we wait, see if a question potentially comes in. Oh, hey Thunder. Your brain big hurt? You want to send a question, or you just saying bad? Oh no. Further mechanics. Oh, I don't know about that. Mechanics. You know what E is? Well, I assume it's not Euler's number in this context. If it's little e, it's probably not energy. It's probably not the charge of an electron. The coefficient of restitution? I've never heard of that. Hey, SG1. I mean, I doubt I'll be able to answer your question, but just out of curiosity, let me, Restitution. Yeah, I doubt it. I'm curious to see what it's about, but, yeah, unfortunately for physics, I'm not aware of a good person who can help you at the times that you're normally on, aside from, like, actual education, potentially, but... Yeah, I'm not sure, to be honest. I mean, I'll try if you want to send it to me. Final ratio of final velocity to initial velocity between two objects after their collision. It's really easy formulae. Okay. Hey, critical. Oh, okay, well, glad it's good timing. It's gonna be a question from Thunder as well. I guess I'll probably look at Thunder's first, but it might be a little bit involved, so if yours is quicker, then... Okay. So yeah, critical, go ahead and post it. Yeah, Hunter, I'll like give you priority. You have a lot. I'm not gonna be able, or I can get you started. What? No, I only just started. I'm hoping to go for like I don't know how long I'm playing. Like, I'm hoping for around 2 hours, but my voice has been a little messed up, so it won't be like half an hour short or anything like that. But it's not gonna be a super long stream today, I don't think. What is this meme? I don't know if it's actually better, but I feel like the people who I've talked to like play basketball, they like it like slightly flat. I feel like someone old made that meme. Okay, so the coefficient of restitution is the amount of kinetic energy that is converted into heat or otherwise absorbed through deformation. Mechanics vectors. Okay. Okay. And you just do the final velocity divided by the initial, and that's the fraction. That's like the percent of kinetic energy that you're keeping, I guess, if you're doing final divided by initial. Okay, so I see that you DM'd me, Thunder. Hello. I'll bring it up. I assume critical poses. I just saw some pop up in the other things. Let's see what criticals was. Oh. I can see you do have a lot critical. I've done some of these for you though before. Or like just on Thursday, right? You don't know what the kind of, oh, so yeah, will you test your endpoints for the interval? Okay, good. So we can skip over the interval part. That's helpful. Right, we can skip over that first like ratio test part, or I'll just like, speed run it. Okay. So Thunder, if you're gonna go do something, I think I'm gonna start going down the list here for critical, and then once you're back, we can dive deeper into your question. I think I've actually done these problems before. I just have to remember how to do it. This actually might not be too bad. Now that I think about it. Yeah, let's at least do like maybe at least 2 of criticals here and then check in. How should I do my screen cap? I guess we'll do this. Ah, who cares? I'm just gonna get rid of that entirely. All right, starting from the top. It's a crappy sigma, jeez. Sigma was dropped on its head. Okay. So that's our first series. N equals 1 to infinity, x to the n over n3 to the n. I'm going to speed run to get to the interval. I can't do this part mentally, so I'm going to write this part out, and then the rest I could probably do mentally though. We're going to get a 1/3. Just times 1/3. So -3 is less than x is less than 3. I hope that agrees with what you got critical. So now when we go to plug in our values for x, I think the positive case will be slightly more clear here. So let's start with that. So here, if we plug in 3 for x, let me actually write that out. We get a cancellation with the 3 to the ends, and I think we end up with a harmonic series. So I'd say that this diverges. Got the same thing? Good. It's like we're able to do the that part of the interval. It's the -3. The first one, you're saying that -3 converges? I agree with that. Because now you get the harmonic series, but it's alternating. And that alternation makes all the difference. So I'd say that our interval is -3 less than or equal to x less than 3. So oh, you said nice, so do you know why that is now, or do you need me to explain this more? I'm happy to do that, but I'm or I didn't do that. Okay, sure. So one of our integers harmonic series that diverges, like we said. Actually write that too. This one, I would just apply the alternating series test because it's a decreasing, and the limit as n goes to infinity of 1 over n does indeed equal 0, so it converges. We don't need to do anything too fancy there. That's kind of the magic of alternation, that it can take a divergent series and make it convergent. Not always, but it often does in the series that we encounter. So it's just an alternating series test, I guess, for that one. So yeah, this is kind of how calculus evolves, where hey, Joseph Albert. I'm doing good. How about you? This is how, like, calculus can evolve with you know, this used to be an entire, this used to be an entire problem that we would do on its own, but now it's just like a little sub problem of a larger problem, which is kind of neat, but also makes it tough if you're not completely comfortable doing these like individual tests. That can make it take a lot longer. X to the n over 2n minus 1. Yeah, Hunter, I'll do this one more, and then I'll switch to yours. Okay. I think we just get x. Because that'll be 2n. That'll be 2n. So yeah, we're gonna get just x, so -1 less than x less than 1. If you ever get a different interval, please do tell me. Doing some limbs, yeah, Milk. Critical's been doing some power series, so we're helping them out. Mostly focusing on the interval of convergence, testing the endpoints. So to test the, I guess it doesn't necessarily matter. There's some tricks you could use to maybe save yourself some work here, but I'm just gonna be procedural and start with the lower endpoint, I guess. Even though I started with the other endpoint before, it's probably a little bit easier to just always start with one endpoint or the other. Or it's a bit easier to like think about. Okay, so we start off with x equals -1. Plug it in here. It's an alternating series. So I'd use the alternating series test because it's nothing that like crazy looking. It is decreasing, and the limit as n goes to infinity of 1 over 2n minus 1 does indeed become 0. So I'd say it converges by the alternating series test. So that's less than or equal to. If you have x equals +1, all good so far? Okay, good. 1 to the n is just 1, so I'm going to write just 1 on top over 2n minus 1. Now for this one, I would say it has the form of the harmonic series. It's just kind of like a transformed version, because if the harmonic series is 1 over n, you could transform that to be 1 over 2n minus 1. So my temptation here is to try to compare it to the harmonic series, which means that I suspect that it diverges. And actually, no, that comparison doesn't work out here. No? Wait, we want it to be greater, or we want the harmonic series to be less than. Oh, interesting. That doesn't work here. So yeah, what I wanted to do, if I want to show that's divergent, I have to show that this is true, but I think that inequality goes the wrong way. Like it actually goes the other way. Right? Yeah, because you're dividing by, this is a bigger number in the denominator, which means the overall thing is smaller. So that's not going to work the way that I hoped, but the way we can get around this is we can do limit comparison. You can even do the integral test if you cared to. I'll do the limit comparison though. And we can use that for our b sub n. And I'll make that our a sub n. So limit as n goes to infinity, a sub n over b sub n. If I unflip the fractions, we get n over 2n minus 1. And you can do the n to the minus 1 over the n to the minus 1 trick. Oh shoot, that's supposed to be limit. I forgot to write that. You get the limit as n goes to infinity of 1 over 2 minus 1 over n, which equals 1/2. So that's a positive finite number, which means that these two series behave the same way. 1 over n diverges, so 1 over 2n minus 1 must also diverge. By LCT for limit comparison test. Yeah, Milk. I wasn't sure exactly how you justify that, like, mathematically, but that's my instinct to like, or like, it's definitely related to like the harmonics. I just couldn't like quite get to like, you know, how do you really justify that like transformation bit? And hello to the fuck boom on YouTube. What's up? No worries, critical. So let's take a look at Thunderfix's problem. And then I'll come back to yours, unless that person on YouTube asks their question. Then we might need to start juggling questions even more. But yeah, we'll do. Drop some formulas that are relevant. Okay. So yeah, the fuck boom, you will go after this question. Or like this is like a quick one, but Thunder's waiting for me to do this question, so just as a heads up to you. A small smooth ball of mass 2 kilograms is moving the XY plane. Smooth fixed vertical wall that contains the line. Wait, how is it a vertical wall that contains the line y equals x? Is it vertical or not? Oh, maybe it has a cutout in the shape of y equals x, so it's almost like a triangle. Oh, so you take a flat wall and you tilt it up so it follows y equals x. Okay. I don't know how you build that wall, but we don't have to question that part. Velocity of the ball just before impact. I was wondering about that too, Milk, but I don't think it's that, or I think it's just a rotated ball that's somehow floating in the air. Velocity of the ball just before impact. I mean, I think that the real meat of it is you have a ball with that vector velocity bouncing up the line y equals x, without trying to think more deeply about it. Any forms besides the unit vector, you can do B and C. Okay. But A gives me a brain problem. Short distance between the sphere and wall is 1/3. Okay. So yeah, we're gonna have to reduce the magnitude of this vector. We want to multiply it by 1/3 or 2/3 times 1/3, I think. Yeah, please do, Thunder. E equals V over U. So E is the coefficient. V is final velocity, U is initial. Oh, hey, so they actually match here. Okay. Well, they use C, but that's our E. V is parallel, and so is U. I don't... If it's running 4 and rising 2, so that's like a slope of, what, like 1/2 rather than 1? V and U are perpendicular. Okay. Yeah, the mechanics of this vector problem are a little tricky. I see what you mean. So we have E and we have U. In theory, we have U. We might need to transform the actual vector that we have. Oh, yes, please do that, Thunder. Because I think I can figure this out, but I would not be confident that I did the vector stuff correct. Okay, so that's the first thing I was trying to imagine is how is this ball actually hitting the line y equals x, and that makes sense to me because this vector basically runs 4 and rises 2, so it must be coming from the left. So v is equal to a plus b, where a is parallel, b is perpendicular. Interesting. 1 over root 2 I plus j is a unit vector in the direction of the wall. Wow, I wouldn't have thought about like this at all. I imagine there's an equivalent way to do it without this construction, but let's follow this. Okay, so I see, they're gonna use the dot product. Okay, so I mean, I'm just kind of accepting this construction as like true, but do you know like where they're getting these unit vectors from for the parallel and perpendicular to the wall? Okay, so let's start with that bit. So that's converting the line y equals x basically into a unit vector. And that's for the purposes of being able to find components of the vector that are parallel to the wall and perpendicular to the wall. Okay. If you're a vector, you take more pride in your direction or your magnitude? I feel like the mainly thing is to take pride in your magnitude, right? So I guess I'll go with magnitude. Okay, so Thunder, I'm just going to draw the line y equals x to start with. And the ball is bouncing off this line, and the ball is expressed in vectors, so we want to find some kind of vector representation for the line y equals x. So I'm going to arbitrarily choose the point 1, 1, and make the vector from the origin that points to 1, 1, and make it a unit vector. So the magnitude of the vector 1, 1 is root 1 squared plus 1 squared equals root 2. So if I take the vector 1, 1, and I divide it by root 2, that's where they get the, shoot, you're not using that vector notation, are you? I plus j. And we would divide it by root 2, which is the magnitude of that vector. So you can also write it as root 2 over 2, or you could distribute that 1 over root 2 in. But you see, okay, good. Now and then we also, so that's the vector that's parallel to the wall. If we want to go one that's perpendicular, I don't know if you can always do this, but y equals x is kind of a nice line. You know the line that's perpendicular is y equals negative x. And I think they just negated the x. Because that would be the point like negative 1, 1 that we could choose arbitrarily again. And so by the same process, you can do negative 1 squared plus 1 squared. To get that perpendicular vector. Got it. Yep. Okay, good. Yeah, so I would hesitate to say that that kind of rule is generally applicable. Like you could always find a perpendicular line and then do that same arbitrarily choosing a point on that line. If there's an intercept though, it'd get a little weirder. Hey Oler, what kind of stuff? So that's where I'm a little hesitant giving like some general advice there, but always for this situation, it's a little bit simpler. All the stuff, 42. So v is equal to a plus b. I think it's just a general bracket, like for order of operations, yeah. But yeah, this part down here is what I'm trying to figure out now. These must all be... No. Okay, so... I assume this is a dot product, but the dot is a little misplaced. And then this on the right is just the actual vectors. Like it's a scale, we're scaling this vector parallel to the wall by the component of the velocity that is parallel to the wall? That's super weird. The dot product, it gives a scalar number. And the more in line the two vectors are, the bigger the dot product. Yes, so like if you have two vectors that are perpendicular, I think their dot product is just 0. If you have two vectors that point in the exact same direction, then it's the magnitude times the magnitude, I guess. Cross a mosquito mountain goat. You can't cross a vector with a scalar. Oh my god, that's a good. I love that one, Mega. I'm about to butcher your name, but I just quit halfway through. Megalomorph. There we go. Geometric meaning of the dot product. Yeah, I think in this case we're using this kind of vector projection interpretation. It is a scalar, right? So I'm still wrapping my head around that myself because my understanding of this is pretty poor, to be honest. It's the length of the shadow. This isn't the perfect thing. So this comes from a physics mechanics question, Mega. And we have a, I think we have a ball bouncing off of a wall. and we're breaking out the ball's velocity into the component that is parallel to the wall and the component that is perpendicular to the wall. And that involves using dot products, which are helpful in finding things that are parallel and perpendicular to a given vector. But I'm trying to kind of generally explain the geometric interpretation of a dot product, I guess, because I don't have a good understanding of that myself, and it sounds like Thunder is in a similar predicament as me. Like, what does the scalar value of the dot product actually represent? And it's, I don't think it's exactly the, if you have two vectors, I don't think it's exactly the magnitude that's kind of in line with your other vector, but it's almost like that. It's like, I might be hard to read on streams, I'm not zoomed in, but like, if you have this vector A pointing up and to the right, and the vector B pointing straight to the right, there's a part of A that is in line with B, and a part of A that's like not in line, like that's perpendicular to B. And so the part of A that's in line with B is the magnitude of A times cosine theta. Like, think that's how much does one vector point in the direction of another vector? Yeah, Glad I don't have like a deeper, that's kind of how I think of it too. I don't have like a deeper understanding it that I feel like I need to explain it to someone else, which is why I'm struggling. I've stuck with a very like surface level understanding, I guess. Maybe the simplest thing to say for now is that the dot product is a measure of how much two vectors point in the same direction. But the actual value of the scalar is a little hard to interpret in a vacuum. Like, you can't just say like, ooh, a dot product of 100 is very high. They're not in the same direction. You can't, it's not that direct of a representation. A dot B equals AB cosine angle, so the multiple of them. Basically, yeah, the cosine of the angle between them is the part that makes it scale with how similar they are. Because like, they always set up a right triangle here. And the bottom of that right triangle could be thought of as the portion of the vector that is like in line with the second one. Yeah, so if you want to dot the unit vectors, then that works fine. But let's maybe not make it more, or try to get the basic interpretation down first, I think. Or like, so yeah, I think maybe a better response, Thunder, is that the actual value of the dot product doesn't mean all that much without more context. But it is often helpful in determining the difference in direction between two vectors. So back to the question, why do we multiply it by the unit vector of the ball? So, right, we're taking the overall velocity vector of the ball, and we're dotting it with the part of the, and we're getting, this gives us the part of the velocity vector that is parallel to the wall, because the dot product, that's just what it does, I guess. That's a very crappy answer. Let me see what Mega is saying. You know what? There might be a simpler way to actually explain this, and it does involve that unit vectors thing that Wildway is saying. But yeah, Meg, I definitely agree. Like, we shouldn't read that much into the actual value of a dot product without further context. But I think here, because one of these is a unit vector, that can help us out here. So what we're doing is 4i plus 2j dot. This is a crappy way to write it, but I'll match with what the answer key does. Okay, just looking only at that part of the answer key. If we use that formula that you wrote, the magnitude of this times the magnitude of that times cosine theta, the magnitude of that 16 plus 4 square root is root 20, which is 2 root 5. It'll be 2 root 5. In this, we made a unit vector specifically because in this situation, the dot product will have a cleaner interpretation, because the magnitude of this is 1 times cosine theta. The vectors are parallel. So, well, let's not worry about the angle yet. Never mind. We're getting the part that's parallel. But the important thing here is that unit vector is 1. So this really is just going to be the magnitude of the velocity scaled by this cosine theta. It's literally, if the velocity vector looks like that, 4i plus 2j, and the wall looks like that, we're literally just taking the portion of the magnitude that's parallel to the wall. Like, you can split up a vector in a parallel part and a perpendicular part. In the exact same way that like a velocity can have an x component and a y component. Yeah, so exactly what Mega said. It took me too long to actually realize that, but that's why in this case it does have a much cleaner geometric interpretation, because we're literally just scaling the vector by the angle between them. Generally, dot product doesn't have a clean. Okay, if Mega made more sense, then I'll take it. I do not take offense to making hearing that I'm not making good explanation, because I'm really not. Also, hey, Linux physics. Let me also give a save to Bladwy for helping out in Linux physics. We're not done yet, but I just want to remember to give saves while it's on my mind. So, nope, that's the wrong thing. That's the right thing. Okay. So we're getting the portion of the ball's velocity that is in line with the wall. And that's the magnitude of the final velocity that is parallel to the wall. We're scaling it, or we're now taking this as a scaling factor to the vector that's parallel to the wall. Hey, Zach. Dude, vectors are like simultaneously simple and really hard. Like, actually computing the dot product is not that hard, but then like the interpretation part is super weird. Because I haven't gotten to why the heck are we multiplying this one down here by 1/3 but not the one up here? That's going to be a problem for later. 3i plus 3j lies on the wall, right? Right. It's an element. Yeah, Bladwy, exactly. Exactly. So 3a plus 3j is the part that's going like parallel to this line. Perpendicular to the surface u multiplied by e. Oh, okay. That's that answers that question then. So for the perpendicular part, it's the exact same reasoning, but we're using our perpendicular vector instead. Except why did they reverse the signs? I think that's fine too. Yeah, it is fine, but like, why did it say this is our perpendicular vector and then they go down here and use this one instead? I think either way it's fine, but that's very weird to me. Well, they use both perpendicular, like they use two different versions of it should give the same answer either way. Perpendicular into the wall versus away from the wall. But yeah, but is there a particular reason why we want perpendicular into the wall? Just being a little sloppy? All right. Yeah, so Thunder, I think you could equally as validly do this with negative I plus j there instead. I have a hard time explaining why they would go out of their way to write it like that, but you want to go into the wall, so your wallward direction is positive. Really? If we didn't have that, I guess we would end up with another negative sign. Oh, wait. Maybe it does matter. I don't know how you would tell that without... No, I don't know, dude. I wonder what the worst explanation that I've given is. This is definitely in the running. I don't think... Sadly, I don't think it's even the worst one. Also, hey, Honeycat. It's in physics, the part that's parallel to the wall is conservative, the parts orthogonal until it bounces. Gets reflected. Which gets a minus sign. Really? Why are we... Because we're basically taking the vector that goes like down here rather than up here. Orthogonal is another word for perpendicular. I mean, you sound authoritative, Honeycat, so... I don't get this. I definitely don't get this perpendicular to the wall bit still with the I minus j. It seems like if we did negative I plus j, we would end up with another negative sign, which is apparently bad. It would get us a different answer. So I feel like it does matter. I just don't know how we know to go into the wall, like Linux is saying. Why are we... So early in the problem, we set up our perpendicular unit vector as negative I plus j, but seemingly randomly down here, they just make it I minus j without explanation. I don't know why we're going into the wall, like down here, rather than away from the wall up here. It'll cancel out the fact that they're taking the negative of the other vector. I don't know where the negative of the other vector is coming from. It might not make a difference, but I don't see why it doesn't make a difference. What counts, I assume, is magnitude, not direction. Well, aren't we doing x dot negative u times positive u? Like what you wrote, Honeycat, seems to match the signs. This one there, the signs are flipped. Unless I'm misinterpreting. Okay, so if I did flip this to be negative I plus j, we would get negative 4 plus 2, which is now a negative 2. And then when it gets multiplied inside here, like we do reverse this direction, it's going to give us a different overall like end result here when we add the vectors. So I guess I'm struggling here. Well, I guess that was already clear. Well, we're getting the reflected we would get we're getting we would get the reflected version at the end here, which is why I'm struggling. Can you go through why doing the dot product of a unit vector and a vector gives you the magnitude in direction? Oh, I can try to explain it again. I'll at least try. I'll try to like fumble through it. So let's just I guess before I even get into that, like, this is really similar to the idea if you just have a, like, you know, any velocity vector you want, let's call it 2i plus 3j. There's some physics problems where you have to split this vector up into an x component and a y component. So like these two portions of the vector add up to the entire vector. And the dot product is doing a very similar thing to a certain extent, except instead of being parallel to the ground, we're now parallel to any other vector we want. So we often just make that other vector like, you know, horizontal, but you're still splitting up your vector into a component parallel and a component perpendicular. And maybe we'll look at chat before I go into much more. Okay, Nothing new, which is fine. So if we want, if we remember that the formula for a dot product is, so say A dot B is equal to the magnitude of A, I shouldn't do another dot, times the magnitude of B, times cosine theta, where theta is the angle between them. If we make B a unit vector, what we end up with is, I shouldn't write it like that. A dot B is equal to just the magnitude of A times 1, which, you know, multiplying by 1 doesn't change anything, times cosine theta. So we're taking basically just the magnitude of this part that's parallel, which you could also think of as just the magnitude of the x direction of the vector. In like the other case where we just have a, in like the simple case where we're worrying about, like, you know, maybe like gravity, like you have the y component that's affected by gravity, the x component isn't affected by gravity, except here it's some other arbitrary vector rather than gravity. So it's, I believe it's basically that vector right there, like this part of A that's in line with B and just the magnitude of it, I think. Oh no, and so saying a parallel part, it like this is the parallel part right here, and then you also have a perpendicular part over there. And if that explanation still isn't working for you, I wouldn't blame you, but my vector knowledge is clearly weak and my ability to explain them is bad, so I don't know what else to say. But it's the same exact idea of splitting a vector up into components. We just care about different components. Like we're parallel and perpendicular to different things than the ground, I guess. Hey, random dude. 3 times infinity equals 25 times infinity to someone. They're both infinitely huge and they're not meaningfully different, I guess. It's kind of like a weird concept, I guess, because there are technically different levels of infinity. That's just not how you get to them. So there's like some like nuance in that. But just multiplying it by a number doesn't actually change anything. Infinity squared or something like that, maybe you're talking. I don't know. Actually, maybe even then that doesn't really work, I don't think. Can you send you an image? Okay. 3 blue, 1 brown is a series on linear algebra. Oh, okay. Infinity equals 23, 25 over 3. That's a great theorem right there, Zach. Hey, Zero Distractions on YouTube. Because like you could get into like mapping sets of the natural numbers to, or you know, mapping a set of natural numbers to itself like times a multiple, but like that's probably a little too much to explain why those infinities are the same thing. Flop, it'll eat your heart out. Mathematicians hate this weird trick. All right, I see your DM, Thunder. We're technically working out the blue lines. Right, the blue lines in your image are the parallel lines. That's what A is. A is the blue lines, B is the red line. Well, I'd say specifically like the upper ones. Um, ah. So yeah, working out what V is by breaking it down into that parallel blue component plus the perpendicular red component. And so this is literally just vector addition, where you put one end of the vector to the other end, and the result is, you know, corner to corner. That's the idea of like this kind of like decomposition. Maybe we should have, maybe that would have been a better thing to establish. That would have been a good thing to establish much earlier on, which I didn't even fully realize for myself until like you prompted me with that. So, hey, Wiranada, I'm probably pronouncing that terribly, but yeah. So that you're gonna send another one, okay? Means I'm gonna get some water. Okay. Let me. True. What about? Or I don't know what the statement is to say whether it's true or not. What are these green lines doing? Hey, Yeri. Cosine x plus sine x equals 1, just interested. I don't know how exactly you do that. Well, I guess, well, no, I guess you have 0, pi over 2, x equals 0 and pi over 2, and every multiple of those, right? Or every 0 plus 2n pi and pi over 2 plus 2n pi, I guess. I don't know if there's other solutions also, but I'm sorry, there's a lot of questions that are waiting, so just sort of a fun one. It's hard for me to get, it's gonna be hard for me to get the time today. And I see your question, Renata. If the sum of its digits is 7. Ooh, I'm not good with those types of questions. I'll paste over to the Twitch chat in case someone wants to take a look at it. Those types of questions are not my strong suit. So I'm not sure if someone wants to take a look at that one, but... Oh, yeah, Honeycat, I was assuming that Yeri meant just cosine to the 1 plus sine to the 1. There is the Pythagorean identity too, but I assumed it wasn't a typo. I don't know though. Let me see what Thunder is saying. So like, you know, perpendicular part, if I take what Mega said, where the unit vector dot gives you the magnitude of that vector, so that's just the green part perpendicular to the wall. To the motion to I minus j. True. Okay, yeah. So yeah, I minus j is that vector right there. you would get, yeah, I think basically something like that, which you would transfer over here, which is still really confusing me. I feel like we're reflecting an odd number of times, so this reflection actually does matter. If we reflected it twice, then I'd be okay, or 4 times, I wouldn't care, but I feel like we're reflected once, and I don't know why that's okay. Exactly that, the Thunder. I minus j is just the magnitude? I minus j is a vector. All we've done is we've reflected the vector that we're dotting with. It's gonna just flip the sign. So like we get 4 minus 2 right there. It would become negative 4 plus 2 if we did what I thought we would do and say negative I plus j. So it's the same number, but the sign gets flipped, and I don't know why that's okay, or why we want that. Like, they end up with positive 2 here, and I thought we would get negative 2, is my issue. And I don't know why that is. Hey, Zane. It's an angle of refraction. It's the result of a ball bouncing off a diagonal wall. It's not light. I can show the original oh, that's not the original problem. That's the original problem. Oh, I hope it went well, Zane. And hey, Scorpra. So working on part A of this, I'm a lot confused, Thunder. And sorry, random dude, I saw that message, but you gotta share with that. Oh, okay. Oh, I mean, that's actually not a bad metaphor to explain why they're really not that different. If you have infinitely many $1 bills, that's the same as having infinitely many, I mean, $25 bills if those existed. Like, you still have infinite money. It doesn't matter what denomination the bills. And that's actually kind of a neat way to explain it. I guess it didn't work for that person, but yes, Thunder. So maybe I think it gives us a vector pointing the other direction, though, when we multiply it in with the actual, like, the issue is when it gets multiplied here, it reverses the direction of this vector, and that's why or I guess it doesn't reverse. Oh. That's what's happening. I think they can see into the future, and like they're basically taking the absolute value of this. Here, let me okay, shoot, Let me show you. I'll just write it out on the board. So we're dotting 4i plus 2j. Dot 1 over root 2 I minus j. Okay. So they do it like this. Okay, actually, no. Let me show the way that we both thought that we would probably do it. Like with this perpendicular vector, and I'll show what the issue is. So they bring the 1 over root 2 out front, which is fine. And then they do x times x, 4 times negative 1, plus y times y, 2 times 1, which is 1 over root 2, negative 4 plus 2. So you get 1 over root 2 times negative 2. And that negative sign is the issue. When we go to multiply it, it's going to reverse. No matter what, we want the resulting vector to point in the direction of negative I plus j. And if we kept that negative sign, it would have reversed the direction of that vector and it would have thrown off the answer. So they looked into the future and just flipped that sign and went back, which is a really unintuitive way of showing it to me, at least. But really, they just dropped that negative sign, basically, is my interpretation. Because it would have messed up the direction of that negative I plus j. Oh my gosh, okay. It's... You know what, that's actually... One second. Dot product. Why would you get a negative dot product? That seems weird, right? Are you supposed to always absolute value it? Means the angle between the vectors is obtuse. Really? I guess that makes sense with the cosine. I have a hard time figuring out why it's obtuse in this exact case, but I think the takeaway is you just don't want to flip the direction of this vector. And so they made sure this vector didn't flip direction by doing that I minus j thing. I think you could also do what we did and just went, oh shoot, we don't want that negative sign, get rid of it. It was relaxing, Zane? That's good to hear. Okay. Sorry, that was such a crappy explanation, but I'm glad that we got there in the end. The fuck boom over on YouTube, if you are still here by some miracle, please let me know. I'll be taking a look at your question. Alright, sounds good, Thunder. Should teach you to ask me a question again. Ugh. I'm gonna bet that the fuck boom probably left. Let me at critical and we can keep working down that list. Okay. And so yeah, I guess it makes sense that dot products would end up being negative. It's just, yeah, just weird, I guess. Okay, so we did 11. For 13, like we did that exact one, right? Were you still unclear on getting the interval endpoints? Oh wait, we did just n, maybe not n factorial. Oh yeah, that wasn't. Okay, 13 is different. I didn't mess up the last time, right? No, yeah, it was just n. Okay. So let's take a look at 13 then. Vectors. All right, what's our series? N equals 0 to infinity. Xn over n factorial. All right, I don't know if we've done a factorial one, at least that you've shown me. So these can be a little bit weird to get used to. Although if you already got the interval, then I guess you figured out that part of it at least. Do you know how to cancel factorials when we get a situation like I'm about to write? Oops. Like we have n factorial over n plus 1 factorial, how we deal with that? So critical, maybe you're still typing, but oh yeah, like, do you know how to deal with this factorial thing and actually okay, I just wanted to ask you that because you said you were able to get the intervals, but I didn't want to speed through this one unless you are like already knew that. So yeah, there's some suggestions going on in chat. There's a couple different ways that you could think about this. The way that I like, I'm gonna bring the x. Oh, sorry, that's x to the 1. I'm gonna bring the x out front. The way that I like to do it, I just like to remember what a factorial means. So factorial of n is 1 times 2 times 3 times 4 dot 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 times n minus 2 times n minus 1 times just n. And that's where n plus 1 factorial is nearly the same thing, 1 times 2 times 3 times 4, n minus 2, n minus 1, n, but we go up to n plus 1 now, and then we stop. And so you get this cancellation of everything except for this very last n plus 1 term. So all we end up with is the absolute value of x times the limit as n goes to infinity of 1 over n plus 1. No factorial or anything. And I think it was Honeycat who posted another way that people like to think about it. Yeah, which is, it feels a little bit more like formulaic to me, but for any number you want, like n plus 1 factorial, it's equal to just n plus 1 times n factorial for the exact reason that we had here. Like you'd say that this bit here is n factorial, and then just stick the n plus 1, like, multiplied on. And so the same thing is true if you had like a 4 factorial is equal to 4 times 3 factorial as well. So there's a couple of different ways that you can think about these, but A lot of times you have a factorial, the ratio test is helpful, and you have to do some kind of cancellation like that. Oh, really, Yeri? I just kind of looked at it and thought about the unit circle. To me, that's like the easiest way, but yeah. It does make sense to be some kind of weird trig identity. Maybe not even that weird. So, are you comfortable with that, like, cancellation? Critical, or like how I got to 1 over n plus 1? Because that's an important thing to be comfortable with for series. I remember getting a lot of factorials like thrown at me. Yes? Okay, cool. Now we get to do our usual tricks. So, oh, you're 0, aren't you? So we get the absolute value of x times 0, which is always 0. And I believe this case means we can plug anything we want in for x. Oh, that makes sense. So our radius of convergence is infinite. I don't know if that's how it's usually written. And that makes sense because I happen to know that's the power series for e to the x or e to the 1. I don't remember. I think it's e to the x. And you're allowed to put any exponent you want for e to the x. Yeah, Brownie. Like, we shouldn't use that for this problem, but it's a nice, like, sanity check. So yeah, I'd say the radius here is infinite because it doesn't matter what we plug in for x, we're always less than 1. I should have said, like, that's the point here. So I guess the interval be negative infinity comma positive infinity. So actually say this doesn't work. You don't have to check your endpoints here because good luck checking negative infinity and positive infinity. So you're just done after this step. So is that okay with you, critical? That's one of those weird. It's kind of like an edge case that can happen with power series where you get a 0 for limit. I think you can also get like infinity there or something, and then your radius is exactly at 0. I don't remember that part at least. The answer is correct. Awesome. Hey, Yanis. All right, let's move on to your next one, critical. We've got x to the n equals 1 to infinity. N to the 4th, 4 to the n. Okay. Little weirder one, but we can do it. Let's do the good old ratio test. Oops. Over x to the n, n to the 4, 4 to the n. A lot of n's and 4s. All right, let's take the x to the 1 out and unflip these fractions. N to the 4th, 4 to the n go on top. N plus 1 to the 4th, 4 to the n plus 1 on the bottom. All right. Well, the stuff inside here is always positive, so I'm going to drop the absolute value over there. We can also cancel a 4 to the n with a 4 to the n plus 1, one up with a 4 on the bottom. n to the 4 over 4 times n plus 1 to the 4. So here, this is another one of those limits where you can do it in a couple ways. You can do n to the negative 4 over n to the negative 4. It'll be a little bit weird in this case, but you could do it. You could do L'Hopital's, or you could do my leading coefficient trick, which, unless you say otherwise, I'm just going to do it. On top, we have polynomial of degree 4. On the bottom, we have polynomial of degree 4, even if it's a little hidden. We know we'll have an n times n times n times n somewhere, so n to the 4th. And that'll have a 4 in front because of that 4. Oh. You object? Why is that? Root test is simpler? Would it be simpler? I was wondering about the root test because of the 4 to the n, but it looks weird with the n to the 4th. You said you had to say something to do it the other way. I had to say something to do it the other way. Oh, okay. Sigma ratio can be interpreted as Zoomer brain rot? I have no clue what that means. But yeah, so that's something we've run into a few times where there's a few ways to actually do it. I like my way, so unless you want to see a certain way, I'll do it the way that I like. So yeah, leading coefficient of 1 up top, leading coefficient of 4 on the bottom. So I'm going to say we get absolute value of x times 1/4. So this will be less than 1. And we get the absolute value of x is less than 4. Or negative 4 is less than x is less than 4. And now we test our endpoints, which we will do. Okay. So I'll be procedural and start with negative 4, because why not? Wow. These sigmas are getting worse and worse. The longer that I stream math, I'm not improving. All right, negative 4 to the n and 4 to the n cancel, leaving behind a negative 1 to the n. I just look at and see a p series with p greater than 1. It is alternating also, so and the alternating test is probably the proper thing to say here. It is decreasing and the limit goes to 0, so I guess I'd say it converges by AST. But I guess spoiler alert, for x equals positive 4, it's just going to be positive 1 in the numerator, and it's going to be a p series. One over n to the 4th. Oh, I should less than or equal to, since they both converge. Hello to Croc of NM. Distribution theory? Dual of test functions, PDEs. Test functions. I think of like stats, like distribution functions. I got the answer right, Critical? Okay, awesome. Well, let me know if you have any like questions on that. That's what I think. That it's symbol from physics I don't understand. Oh, my sigma, see, Harry? Yeah. No, I'm just lazy. It does, I'm actually, the sigma second from the bottom looks a little like capital gamma even. I guess it's flipped, but anyway. Um, yeah, so I don't know what a test function is, but it sounds like Zach has seen them before, or e to the 2 pi. So, oh, true. Yeah, capital pi. Like, Croc, if you want, you can put the question here in chat, but you may want to try Zach when he streams next. That's his link there. I believe his next scheduled stream is on Tuesday. It looks like Gamma, yeah. But regardless, welcome in, Croc. I just haven't seen test functions before, so I'm not sure I'd be able to help you out with that. I don't know what those are. In general, if you're looking for math streams, though, here's a whole list of math streams so I can like recommend. Hey, Jed. Yeah, sorry, but I guess Zach is probably your best bet. And if you want, you can hop in Zach's Discord as well, where you can post a question now, or you can post it on my Discord too. But you might have better luck than Zach's, if anyone can help you at least. Or you can put it here in chat too. But yeah, sorry if that's information overload. Okay, well, sorry, Zach. I just realized I was like talking you up a little bit, so. Sorry, Zach. I'm like, oh, someone else wants to handle it. Oh yeah, you take it, not me. You're about to make the same joke. My domain is all real numbers. I'd say that I'm best with like lower level university math and below. So like first and second semester calculus, a little bit of multivariable, some differential equations, a tiny bit of linear algebra, and anything below that like pre-calc, trig, geometry. Well, geometry, please. I forward all my geometry problems to Jed, but don't ask me to add 2-digit numbers. Yeah. So I'd say my math knowledge tops out around like first or second year undergraduate math courses. Maybe the simplest way to say it. Differential geometry? No, I never took a class in that, unfortunately. Now with the group theory and like, oh my god, it's lambda? Oh, I haven't gotten to any lambdas yet in group theory. Interesting. Oh wait, imbalance? I assume that was like some weird abbreviation for lambda. I don't know what imbalance is either, to be honest. All right, sorry, critical for the non sequitur. I can get up your next problem here. 30 days of... Oh, wait, that's a 30... I heard that as 3-watch streak. Wow, Jed, 30 days, nice. Thank you very, very much for that. Exactly. Differential geometry 1? Probably not for a long time. I'm very interested in the E&M stuff, and I don't want to take on more self-studying than I'm already doing. Plus the algebra. All right, so critical, your next one. I mean, it's literally Calc 4 in some universities, isn't it? Like, it's just regarded as a fourth semester of Calc, I thought, in some places. We have n equals 1 to infinity. -1 to the n, 4 to the n. Dude, there's so many n's. Over root n. That's not all, folks. Don't touch those remotes. X to the n. Okay, that's all, folks. Touch your remotes. Number of letters in the capital of California plus the fourth triangular number. Oh God. Okay, here. Well, I'm gonna do Zach's quick math. California. The capital is Sacramento. SACRAMENTO 10. The fourth. I don't know triangular numbers, dude. I'm googling that. 10? Oh, 100. Wait, you said times, right? No, plus 20. I was multiplying. I refunded your points. That's embarrassing. Oh my God. I got the individual numbers right. I got the operation wrong. Let's do our ratio test. Four to the n plus 1 over root n plus 1 x to the n plus 1 over 1 to the n 4 to the n over root n x to the n. Okay. I'm going to take out the x to the n like usual, or the x. Got a big fraction here. Okay. Now let's look for cancellations. -1 to the n plus 1 cancel with -1 to the n. Relative with -1 to the 1, which is just -1. We have 4 to the n plus 1 over 4 to the n, which cancels and leaves us with a 4 to the 1. And then the root n plus 1 and the root n don't really cancel. They stick around. Absolute value this stuff, so we just get rid of the -1 is all that means in this case. Everything else is always positive. So we get 4. Actually, I'm going to rewrite this in a slightly different way. We get 4, and then that's a square root, and that's a square root, so I'm going to write it under one big square root. Is there an easier way to do this? Like a less sketchy way than what I'm about to do? We've seen a limit like that before. I brought the limit inside the square root, which is probably theoretically sketchy, but it's usually fine. Oh, too late, Zach. I already refunded. Okay. So the 4 can come out front. It doesn't affect the limit. And I'm going to bring limit inside the square root. Again, I feel like that's kind of sketchy, but it works to get the right answer. And I feel like it's allowed at least. I don't know how else you really quickly do that. And that, if you use the coefficient rule or the n minus 1 over n minus 1 trick, you get that to be 1. So we get just 4 times the absolute value of x. We make it less than 1. Divide by 4, and you get the absolute value of x is less than 1/4. So that means our radius is 1/4 already. And then we need to figure out our interval of convergence. Oh, not absolute value. So we gotta test our endpoints and see if they're included or not. The prime factorization of the number of minutes in an hour. The prime factorization of 60. $60 is, how many 2's can we put inside 60? 2 of them? 2 squared is 4. Divide it times 3 times 5. That's a 5. Sure. Because 15, yeah. 2 squared times 3 times 5. Hey, okay. I'll take those points then. Okay. So let's go and test our endpoints now. I'll start with -1/4. Okay. Oh, I'm phoning these sigmas in, dude. I completely given up. Look at that one. So it looks a little weird, but this 4 to the end and the -1/4 to the end, we do it a cancellation there. It's still just a 4 to the end up top and a 4 to the end on the bottom. We do get a -1 to the end. So it'll actually be a little bit of a weird situation. We still have that -1 to the end also. So we get -1 to the end from that one, and then this becomes a -1 to the end, and that root n is still chilling out. It looks weird, but we can absolutely deal with that -1 situation because it's still the same base, so the exponents add, and n plus n is 2n. And when you have an exponent like that, we can write it equivalently as -1 squared to the power of n. And -1 squared is +1, and +1 to the n is just 1. So really, -1 to the 2n is just 1. Another way to think about it is -1 to any even power, which is what 2n is. 2n is an even number. So -1 to the power of an even number is always +1. So what the series really is, if you pull off the Mass Effect and Scooby-Doo, is +1 over root n. That's a p series, but p is less than 1, so it diverges. That's for the first endpoint. Yeah, Jed, I do that way too much. In my defense, it's really hard to stream and do math at the same time. Let's check our other endpoint now for x equals 1/4. And when checking endpoints, especially when it's the same number, just one is negative, one is positive, the work we just did here can give us a hint for what to do down here. So in the work we just did up here, we had 4 to the n cancel with that 4 to the n on the bottom, but we still had the negative sign, which gave us a -1 to the n. The only difference here is we don't have that negative sign. So it's just going to cancel and become +1. So instead, we're going to end up with n equals 1 to infinity of -1 to the n. Just alone up here, there's no extra -1 this time over root n. Now this one, I would use the alternating series test because it's decreasing and the limit of 1 over root n as n goes to infinity is 0. So I would say this one converges. So our interval, we stick an or equal to on that one. And I call that problem solved. Is that good with you? This one, it definitely is. Hey, Phobos. Was there any part in there that I lost you? Because I know there are like a couple like weird parts to that problem. The first one? Okay. The cancellation with the -1 over 4? Yeah, I can go into more detail on that. So I'm trying to go through these like a little bit fast. So Because again, like my voice isn't feeling too great, but if you need me to slow down at any point, like please let me know like you did. -1's the end, 4's the end, root n. So all I'm doing right now is just repeating the problem. When you have a fraction to a power, you can distribute that power to the top and to the bottom. That's what I did in my head without saying. So the negative sign, it's kind of ambiguously placed. You're allowed to put it on top or bottom. It's going to look a little bit easier if we put it on top with the 1. So I'm going to distribute the power to the top, -1, and to the bottom, +4. And I hope this makes it clear what's actually happening. The 4 and the 4n cancel. The -1's the end, and the -1's the end. So we get over there. So all I'm doing is distributing the exponents to the top and bottom. The negative sign is a little bit weird because we write it in the middle for fractions a lot, but that negative sign can float to the top or the bottom, and it's completely the same. Hey Cruz, do you do mathematical logic? Are you talking about like what's it called, propositional logic? Yeah, either way, you can put the question in chat, so I'm sure that someone can. I technically learned it. I don't remember it that well though. Then P series, it was just P series. Yeah, that's because maybe I explained the wrong part of the problem. Just because we have that -1/4 there does not mean it ends up being an alternating series after you simplify it. It's because it's basically double alternating. So we already have the -1 to the n out there, and we have another -1 to the n hidden inside this fraction. So just because there's negative signs in there doesn't mean it's actually alternating. It's just not simplified yet. For the exact reason that we saw here, -1 to the n times -1 to the n is always +1. So even though it's deceptive and it looks like it's alternating, it's not actually alternating. Croc, thanks for the follow. So just because it has a -1 to the n inside the series does not mean that it's alternating necessarily. And I feel like I may have told you the opposite before, but that's because we were only ever working with series that were fully simplified. In the case that we just looked at now, the series was not fully simplified. So that's kind of like the difference there, I guess. But I feel like every time I tell you a general rule, it gets broken at some point, so. Oh yeah, and Brownie Man gives another way to like think about the same thing. Cruz says if x is greater than y and x squared is less than y squared, implies y is less than 0. I need to show it in the not way, like by contradiction. Yeah, y would have to, or yeah, y is negative, and you assume y is positive, I guess. Hey, Fembox. Oh, yeah, sorry, you said something in chat before and I forgot to say hi. Sorry if I ignored you. So critical, I hope that alternating bit is good with you, or let me know if you're still unclear on it. It is? Okay. Like a less than b prime. Yeah, it'd be a little bit sketchy on how to actually prove this. So Kirkle, I'm gonna take like a 1 or 2 minute break from your questions to talk a little bit about quizzes. So I feel like this might be a notation thing as well, that I don't know how it's gonna be represented in your class crews. But you want to prove the statement, if x is greater than y and x squared is less than y squared, then y is less than 0. Let me make sure I copy that right. And you want to do it, you're saying the not way, which I interpret as proof by contradiction. So we would assume, I guess, to try and write it the way that you're writing, like y is less than 0 prime, which is, we'd assume that y is greater than 0. I'm probably not writing the exact way that you need it. I think we're showing it in the other statement. The long one. Oh, maybe it's like contrapositive or some other. Oh, those I really don't remember that well. Because you can, like, the contrapositive is the same as the original statement, right? And you can try to prove the contrapositive. Okay, so, okay, thanks for confirming that, Bladwy. Now, I'm not sure if that's what Cruz is still asking about. That's a very red website. But if we're not doing contradiction, then maybe you're saying you need to prove it by y is not less than 0 implies, it's probably a bad way to write it, but and x squared less than y squared prime? Like, are you supposed to do that, Cruz? I forgot to take the cam down. Oh well. All right, see you, Yanis. Thanks for hanging out. I'm not seeing anything from you, Cruz. I guess I'm not sure how you're supposed to prove this. I guess... Yeah, I'm not sure. Can we do only the right side turn into double prime? That's right. You do prime only on the right side, and then you turn it into double prime to show it's right. I don't think it's contrapositive now. This feels like maybe it is contradiction, but maybe phrased in a weird way. Or weird to me, at least. So it sounds like, Cruz, you're starting with this. And my guess is that you're showing that this is not true. This is what you did. Okay. Let's take a look at that. That might help. All right, x is greater than y, and x squared less than y squared. Y less than 0. Okay, that's the original problem. For all x, y, and r, oh, did you, or I don't know which problem you solved, Croc, but if you want, you can do what Cruz did and like upload it to a website, or you can post it in my Discord. The equal sign is wrong. Yeah, I'm not sure what's happening here with why we negate the left side. Like, we might... You could say that, like, this statement here is equal to this statement right below it, but we might want to remove the y is less than zeros entirely. And then if the plan is to like bring the negations inside the actual statements, you would say x is less than or equal to y, or x squared is greater than or equal to y squared. I don't know what you necessarily do with that, though. Yeah, I think it'd be valid if we just didn't write the y is less than 0 part entirely. I don't know how you eventually end up with... I don't know what you want to end up with if you're negating this in the first place, I guess. If that's you just joined, you can put it in the math discussion channel, I guess, or wherever, really. Yeah, I'm too rusty on this. I'm sorry, Cruz. I don't know if someone in chat wants to give better or wants to give some advice on it, but I don't know of a good strategy to actually show this. Like, the statement makes sense to me for why it's true. I just don't know how to actually like prove it in this way. It looks like what Yeri's put makes sense to me as the negation of the original statement. I think it's a negation. Like, done properly. So you maybe even take Yeri's, what Yeri put and have as like your last line. I guess you would need to move the y less than 0 over here and also negate that. Or just reverse the direction of the arrow. Yeah, I'm not sure exactly. I assume... I mean, it's proving this first statement. I just am unsure of the strategy that we're supposed to use. It should be true. Like, this is x is greater than y, and x squared is less than y squared. The only time that can be possible is if y is negative. It's like you have x equals 2, y equals -4. Yeah, I guess like this is like I guess it's a translation thing. It's like the not way can mean a few things. So I'm sorry the translation part is so like difficult. I just even if I did know, I still don't remember this that well. I'm going back to some of Critical's series. I don't... Critical, are you here? Let me at you. Okay. My voice is not going to hold out for all these questions. Do you want to choose like maybe 2 more? I simply can't do all these. Okay. If you want to see like at most 2 more today, I can do that for you. But if not, oops. I gotta give my voice a break. Trying to think if who will be streaming as well. I think Stuki is back on their normal schedule to stream tomorrow, potentially. Yeah, I'll be around on Tuesday. Zach will be around on Tuesday. Likely Dan will be on... Well, on Monday, I think there's going to be some games. But yeah, on Tuesday, as long as my voice is healed up, I should be good to go. Um, yeah, I think I need to call a stream here though, because I'm feeling it in my voice. So, no worries. Let me see if there's anyone who's streaming. Hey, Mom Petite Poop. Thanks for the work. Have a good voice. I mean, night. Yeah, I mean, hopefully both. I don't see anyone streaming the math category. Let me take a look. We could raid out to like Moo Hoodles. See if she's going, but if there's anyone, I raided Talus a bunch recently. Okay. Thank you, Merrick Dead, for the follow. Okay, yeah. Let's go raid out to Moo. Oh, awesome, Fembox. I am getting close to the end. I got through Gauss's law. I'm still trying to wrap my head around their derivation of it. But it was a pretty neat, like, fact. Yeah, I there's like a couple of like I'm trying to figure out a couple of the geometric issues with like the r over r squared factor, why exactly that works. But I'll think about it more, or maybe even bring it up during the actual session or something. But yeah, thanks so much everyone who's been hanging out with me. Normally I stream for longer. Oh shoot, I need to stop the YouTube stream. Bye YouTube.